and coefficients of polynomials. Okay, so roots and coefficients of polynomials. Exercise 12.6. I'm going to do a couple of examples, more than a couple. Okay, we're going to go straight to question 4. So, no, we're not. We're going to go straight to question 5. Question 5, because, girls, the other questions are really basic and we'll be covering that sort of stuff in these questions. Question 5, if alpha, beta, and gamma are the roots of 2x cubed plus 5x squared minus x minus 3 equals 0, you have to find the following. So question 5, if alpha, beta, and gamma are the roots of 2x cubed plus 5x squared minus x minus 3 equals 0, find the following. A, find alpha, beta, gamma. Now this is what I want you to do on the side. Alpha plus beta, or one at a time. What's roots one at a time? Sorry, now I've come off screen. All right, what's roots one at a time? Just, isn't it minus b on a, and 2 at a time is? Sorry, I'll come off. Is c on a, just 2 at a time is c on a, and what's 3 at a time? Or product. So that's 1 at a time, 2 at a time, 3 at a time. 3 at a time happens to be the product. Are you okay with? Yes, we've got the product. So girls, this is what you think. You sit there and you think, okay, I know these. 1 at a time is minus b on a. 2 at a time, and I didn't write them all out because there's 3 of them, is c on a. 3 at a time, or the product, is minus d on a. Got it? So what's a, b, c, d? Let me write that out here. What's a?
2.
What's b? What's c? And what's d? Okay, we can use that for all our questions. So this is just my little bit on the side. Okay, so 3 at a time is minus d on a, which, it's product, which is 3 at a time. Product, or 3 at a time, same thing. Product in this case is 3 at a time. Okay, so what's the product in this case? Minus d on a, which is negative 3 over 2, which is what? 3 on 2. Just keep it as 3 on 2. Question B. What's this one? What's that one? Alpha beta plus alpha gamma plus beta gamma. 2 at a time is c on a, which is, you get it, girls? 5 on 2. I'll write question C for those that are waiting. Question C happens to be what? Sum of roots. How many at a time? That's the normal one. Minus b on a, which happens to be minus 5. Girls, did I make a mistake? Thank you. Minus 1 on 2. Fix it up. Thanks, girls. C on A is negative a half. I'll just put it up here instead of using all that. Sorry. So 2 at a time is C on A, which happens to be negative 1 on 2. Sorry about that. 1 at a time is minus B on A, which is negative 5 on 2. Sorry, girls. No. Right, close the door, please. 1 on alpha plus 1 on beta plus 1 on gamma. You did this similar thing in 2 unit. What did you do with those? Yeah, you made a common denominator. So what would the common denominator be between those 3? Alpha, beta, gamma. So what's the first one need? Beta. Yep. What's the second one need? Alpha. And what's the last one need? Alpha, beta. So girls, looking at that, isn't that just your answer to sum of roots 2 at a time? divided by your answer for sum of roots 3 at a time? So it's negative a half divided by sum of roots 3 at a time is divided by 3 on 2, which is, see, it's not that hard, is it, girls? Which is negative a half times 2 on 3, which is negative, no, the 2's cancel, negative 1/3. Girls, you need to learn how to cancel before you multiply, please. When multiplying fractions, do your cancelling out first where you can, all right? And E is this, alpha plus 1, beta plus 1, gamma plus 1. I know. All right, I'm going to move it. All right. Now, there's no rule for that one, so you're going to have to do something, expand.
So is it alpha, beta plus alpha, gamma?
Yep. Alpha, beta plus, can you all go and expand it on your own now? Alpha, beta plus alpha. No. Girls, multiply the first two together, please. Alpha, beta plus alpha plus beta plus, girls, I'm doing the FOIL method with the first two. Plus what? Alpha, beta plus alpha plus beta plus 1. Girls, times gamma plus 1. So we've just, sorry girls, I'm off the screen now. So I've just multiplied the first two brackets, got it? Now we're going to multiply everything by, look, do you like to multiply them all by the gamma first and then by the 1? Or do you like to do it by each of them? I'm going to multiply them all by the gamma first, because then I know just to throw on a gamma. Do you know what I mean? Plus, multiplying them all by 1 means rewrite them. So girls, what I've done, I multiplied them all by gamma first. It makes it easier because you're just putting a gamma. Look what I made a mistake. All right, I just put a gamma on the end of each one. That's a gamma. And then, well, you're multiplying them all by 1, so you just rewrite them. Does that make sense? I'm multiplying them all by gamma, so throw a gamma on each one, and then multiplying them all by 1, keep them the same. So, girls. So, girls, what have I got? 3 at a time plus, how many 2 at a times do I have? 1, 2, 3. And do I have all the 1 at a times? You'd hope so. And I've got the number 1. Girls, can you see? Girls, this question 6, 4 at a time is E on A, which is, you can write out your A, B, C, D, E there, and your rules for 1 at a time, 2 at a time, 3 at a time, 4 at a time. 4 at a time is E on A, which is negative 3 on 1, which is negative 3. This part B is 3 at a time, which is minus D on A, which is negative 5 on 1, which gives you an answer of negative 5. C, you need a common denominator, and the denominator will be alpha, beta, gamma, delta. You know you're going to have, yeah, the 3 that are missing there. Yeah? The 3 that are missing there. The 3 that are missing there. No, plus B. Oh, yeah. Alpha, beta, gamma. So it's the 3 at a time result. Negative 5 over negative 3. Good. Not too bad, but these are the easy ones. Question 8 from exercise 12.6. It says 1 root of x cubed minus 5x squared minus x plus 21 equals 0 is 3. Find the sum of alpha plus beta, which is the other 2 roots, and the product alpha times beta. That's a times. Alpha beta means alpha times beta of the other 2 roots. Girls, it doesn't matter if we call them alpha beta, because the first one was 3 and we're calling the other 2 alpha beta. You don't have to go and call them beta gamma. Do you know what I mean? All right. So what are you going to do? Sum of roots. All right. So do you know your rules? We've got minus B on A. That's the order, isn't it? C on A minus D on A, because there's only 3 roots. So sum of roots 1 at a time will be minus B on A, 2 at a time is C on A, product, or 3 at a time is minus d on a. What do you think that they're asking you to do? All right, what are the sum of the roots? Let's do sum of roots. What are your three roots? 3 plus alpha plus beta. What does that equal? Negative b on a. What is a? Let's put that up here somewhere too. A is 1. B is negative 5. C is, and D is 21. Okay, that's what we've got. So sum of roots, one at a time, is minus b on a. So 3 plus alpha plus beta is minus negative 5, which is 5 over 1. So what do you think you're just going to do now? Just move the 3. It's not hard. Okay? Be careful with the next one. Are you going to do 2 at a time or 3 at a time for the next one? Because if you do 2 at a time, you're going to end up with beta gammas and alpha gammas, and you don't really want those. So just try 3 at a time. It's always best to do 1 at a time and 3 at a time. You'd only do 2 at a time if you really needed to. All right? Let's do sum of roots, or well, once it's 3 at a time and it's a cubic, it's called the product. Does that make sense? Always the last row is called product, because it's just the product and no more sums. Product of roots is 3 times alpha times beta. You got it? That is what? 1, 2, 3 at a time. So it's negative d on a. So it's negative 21 on 1. So what are you going to, good. Almost good. Negative 21 over 3, which is negative 7. Girls, because product of roots, sorry, I should have written the formula down, is minus d on a. I should have written that down in there. All right, I'll go minus d on a. Are we okay with that? Minus, always write the formula. It's minus d on a, which is minus 21 on 1, which is minus 21. So alpha times beta is negative 21 over 3, which is negative 7. Now, question 10. Yeah. Yeah, but, all right, we'll try not to finish them. Girls, did you write down that this is extension 1? Yes. Now, obviously, this book's a lot easier than Cambridge. I'm going to have to get you some Cambridge stuff next time we look at this. Oh, wait, I don't want to do that one. It's only quadratic. Rip that one out. All right, we'll do 11. I don't want to do the quadratic ones. You've done them. Question 11. I might set that one for homework, actually. That'll be good 2-unit revision. So I will set question 10 for homework because it's 2-unit revision. And so is question 7. That's 2-unit revision. Any quadratic ones are 2-unit. The cubic are 3-unit. All right? So question 11. So girls, but this is still good revision for 2-unit because the method's still the same. So 2 roots of x cubed plus mx squared plus 15x minus 7 equals 0 are equal and rational. Full stop. No. Find m. So 2 roots. Now, see, you've got to look at this. So 2 roots of that equation, x cubed plus mx squared plus 15x minus 7 equals 0 are equal and rational. Now be careful. First, name your roots. 2 roots are equal. Alpha, alpha, and beta. 2 alphas, not 2 times alpha. If 2 of them are equal, so this is what we're going to do. Let the roots be alpha, alpha, and beta.
Why do we have 30?
Well, because it's a cubic. It's a cubic. It's got 3 roots. And we know that 2 of the roots are equal and rational. So we still have to, if you're doing anything with a cubic, you've always got to be looking at the 3 roots. All right?
If it said it was irrational,
Well, it's not like b squared. See, this b squared minus 4ac stuff is only for quadratic. So you can't use that here. It's just that the answer you get has to be rational. So if you have an irrational one, then you've got to ignore that one. So let's just see what we get. Because they want us to find M. And what is A in this, by the way? 1. What's B? So it'd be really good to use the B, wouldn't it? Because that would put the M into your equation. What's C? And what's D? Now what you use, we're going to have to use the equation with M, but I think we're still going to have 2 unknowns. So we're going to have to try and use another equation as well, because we might end up with simultaneous equations, all right? It's really hard to use the 2 at a time one. It's much better to use the product. So it's really good to always use 1 at a time or 3 at a time. Sometimes you use 2 at a time, but the most commonly used ones will be 1 at a time and 3 at a time. The problem with using, anyway, we'll just see. We might have to use the 2 at a time. I don't know. What we do, we start going through it. We'll try 1 at a time. We'll try 3 at a time. If we can't get anywhere, we might have to try 2 at a time, all right? All right, let's go with 1 at a time. The reason we're going to do 1 at a time because it gives us the B. Do you know what? It gives us the M. All right. Alpha plus beta is minus B on A. So what? Yeah. So what's alpha plus alpha? 2 alpha plus beta is negative. So that's negative M on 1, which happens to be negative M. Now you know you need another equation. Why? Because you've got alpha and betas. You've got 2 unknowns. I think we might even need 3 because we've got an M as well. But we'll just see. Equation 1. Let's try 3 at a time. See if that works. Because you only go to 2 at a time if there's no other option that's going to work. Right. Alpha. How do you do 3 at a time? Alpha times beta. So what does that give us? So 1 at a time is minus B on A over here. That's right. 2 at a time is C on A. This is 1, 2, 3. Whoa, see? 1, 2, 3 is on the side. All your stuff's over here. All right, what do we got? 7, negative 7 over 1, so it's 7. So alpha squared beta is 7. Got it? All right. Yes. I think, should we try and just substitute? Why don't we rearrange equation 2? What are you going to make the subject? Oh, I don't know, actually. Or you can rearrange equation 1. That's right. Make beta the... So rearranging equation 1, I would put... What do you want to make? I'd make beta the subject. We would get beta is negative M minus 2 alpha. And let's put that in there. And now we've got an equation. This is good. Very good. Because when you're rearranging 1... and sub into 2, all right, this is going to look good. What do you get? Alpha squared times what? Minus M minus 2 alpha. Oh, we've still got an M.
Equals 7.
All right, so we've got negative alpha squared M minus 2 alpha cubed. Oh, I think this is that question. Yeah, we can take out alpha... Oh, I know what's happening here. Okay, we're just going to try 3 at a time. So this was 2 at a time, roots 2 at a time, This was roots 1 at a time.
You're on camera.
Yep. That was 1 at a time, 2 at a time.
No, that was 3 at a time.
Oh, that was 3 at a time. One sec. Before we keep recording, let's just have a look. Let's try sum of roots 2 at a time. They're the roots up there, so wouldn't it be alpha squared plus alpha beta plus alpha beta? They're the combinations. It's alpha squared, alpha times alpha, plus alpha times beta, plus alpha times beta. What's that? 2 at a time is C on A. So we've got alpha squared plus 2 alpha beta is
15.
C is 15. 15 on 1?
Equals 15.
All right. Okay, girls, got it. Now we can do it. We can do it with equation 2 and 3. See? Oh, there's already a 3. 2 and 4. Do you know why we can just do it with 2 and 4? Because there's alpha, beta, and a number, alpha, betas, and numbers. The problem with equation 3 was the m was in there, and you've got 3, and you've got... So girls, yes, but you can find out alpha. Once you find out alpha, you can put it in there. Oh, no. We're doing now, we're going to solve, could you try and solve equations 2 and 4 simultaneously, please? Because they're the ones with only alpha, beta, and number, alpha, beta, and a number, okay? What we've done here is, there's equation 2 and equation 4. We're rearranging equation 2 to make beta the subject, so beta is 7 on alpha squared, and we're substituting that into this equation 4. So we get alpha squared plus 2 alpha times 7 over alpha squared equals 15. You can cancel between the numerator and the denominator. This is really 14 alpha over alpha squared. Do you see that? It's 14 alpha on alpha squared. So don't one of the alphas cancel? So you get alpha squared plus 14 over alpha equals 15. I've got a cubic. Even worse. Alpha cubed plus 14 equals 15 alpha. Alpha cubed minus 15 alpha plus 14 equals 0. We need to think back to the polynomials topic. Do you remember when you're looking for the first factor? When you're looking for one of the roots, you do the factors of 14 and you see whether one of those will be whether they solve the equation. Do you remember that, girls? When we did the polynomials topic and you're looking for your first factor to factorize. Yeah, so I don't think let's try 1 or -1 and then we're going to try 2 or -2. So, the solution to this, we're going to go back to our polynomial stuff where we're looking at factors of 14. Because to get this number 14 here, 3 numbers must have been multiplied by each other. So we look at the factors of 14. They could be plus or minus 1, plus or minus 2, plus or minus 7, or plus or minus 14. We try these, starting with maybe plus 1, into this equation, and it works. Minus 15 times 1 plus 14, what does that equal? 1 minus 15 plus 14 equals 0. So therefore, x minus 1 is a factor, or one of the roots. One of the roots is 1. If you put -1 in there, it's not going to work because you get -1 plus 15 plus 14. That doesn't work. We can sit here and try and work out this other root right now. Try 2 isn't going to work, I don't think, because you get 8 minus 30 plus 14. That's not going to work. That's not going to give you 0. Okay, but it only says that 2 of the roots are rational. So I think we should go that alpha is 1. Or it could be the beta. Let's just keep going. Let's look at -2. I don't think that's going to work. -8 plus 30 plus 14, no. We could try, does someone want to try 7? 7 cubed minus 15 times 7 plus 14? No. +7 is not going to work. And 14 is not going to work.